Hi all, I am Divya Somakumar and in this video we are going to learn how to build a machine learning model from scratch. In this video, we are going to do exploratory data analysis on our data. We'll be doing some pre-processing on the data. After EDA and pre-processing, we'll be moving on to feature selection. We will be using principal component analysis to identify the most important features in our model, and we are going to fit a model based on the important features selected by the principal component analysis. At the end, we are going to check for the accuracy of the model using the different evaluation metrics. Now, let's jump start and begin by importing our necessary libraries. Import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import cborn as sns, import warnings dot filter warnings. We ignore the warnings. Now we have to import our dataset. We are working with Google Colaboratory, so Colab works in a different style. Over here on the left hand corner, we have files. Over here, we have an upload button. We'll upload the required files and then we will load it onto the Google Colaboratory. So for this, I have taken the data on USA house pricing. I have taken the data from the Kaggle website. I will provide the link for the same in the description below. Now our housing.csv is getting uploaded onto the Google Colab. Now we will see if the dataset is uploaded. Now we will load our dataset. df is equals to pd dot read underscore csv housing dot csv. Now let's look at the head of our dataset. df dot head. Now we have longitude, we have latitude, we have housing median age, we have total rooms, we have total bedrooms, we have population, we have households, we have median income and median house value and ocean proximity. So over here our target variable is this median house value and all other variables are our features. Now let's do a little more exploratory data analysis. Let's check the info so that we come to know how many rows and columns are there. df.info. So we have around 20,640 rows and we have around 10 columns. If you see, all the columns are numeric data types except ocean proximity, which is an object data type. In a short while, we are going to convert this ocean proximity, which is a categorical data type, into a numerical data type. Now, we are going to perform some more exploratory data analysis. We are going to look at the descriptive statistics. How do we do that? df.describe. So what does describe say? Describe gives us a data frame of descriptive statistics of the numerical data types. Now, here we have the count, the mean, the standard deviation, the minimum and maximum values, the 25th percentile, 50th percentile, and 75th percentile. Now, we have to do the correlation matrix. Now, we'll find the correlation matrix by writing df.cor. So the correlation matrix gives us the correlation between different numerical columns. Now, if you look at this matrix, you will not find it pleasing, or you will not understand what is the relationship between the different numerical variables. Hence, to make our life simpler, we are going to plot a heat map. A heat map will show the different degrees of correlation between different variables using different colors. Now let's make a heat map. How do we do that? SNS dot heat map pf dot core. We will write a naught equals true, a naught equals true, so that we can come to know what is the correlation. Now we have got our heat map. The lighter shade indicates that there is high positive correlation, and the darker shade indicates that there is high negative correlation. Now let's see if our data has any missing values. How do we do that? Tf dot is ne dot sum. So, our total bedrooms have 207 missing values. How are we going to handle these missing values? We are going to replace all the missing values in total underscore bedrooms by the mean value of total underscore bedrooms. So, let's handle the missing values by first finding out the mean of total underscore bedrooms. B mean is equals to PF total underscore bedrooms dot mean mean. So we have found the mean. Now we'll replace all the missing values by this mean value. How do we do that? Df total underscore bedrooms dot fill na. What are we filling the na with? We are filling it by b mean, comma, in place equals true. Remember, if you do not write in place equals true, then the changes will be temporary. To make the changes permanent, we have to write in place equals true. Now, let's check if there are any more missing values in our data. Pf dot is ne dot sum. Now there are no missing values. We have successfully handled the missing values by replacing the missing value by the mean of the column. Now, we have seen that ocean proximity is an object data type. And we know that if we want to perform a machine learning model, all our data should be in the form of numbers, because our machine only understand number. It doesn't understand anything which is not a number. Hence, we have to convert all the categorical variables into numerical variables. How do we do that? We are going to use label encoding to convert our ocean proximity into a numeric data type. Now let's do that. How do we do that? From sklearn dot preprocessing import label encoder. Let's run this. Now let's create an object for label encoder. Let's call it LE. LE is equals to label encoder. Now our object for label encoder is ready over here. Now we are going to fit this onto our ocean proximity column. So how do we do that? Le dot fit underscore transform. What do we have to transform? We have to transform the ocean proximity column. So we write ocean underscore proximity. Remember that fit underscore transform doesn't have an in place is equals to true parameter. So to make the changes permanent, we'll have to reassign it onto the column itself. So we write df ocean underscore proximity is equals to le.fit underscore transform df ocean underscore proximity. Now let's check the head, whether it has converted all the non-numerical data into numerical data. Now let's check it. Yes, ocean proximity, which was initially a categorical variable, has been converted into numerical variable. Now you will observe that all our columns are measured in different units. Basically, they do not have the same unit. Like median income is measured in dollars, population is measured in numbers, number of bedrooms and number of rooms are measured in number of rooms. Age is measured in terms of years, latitude, longitude is measured in terms of their units. So we do not have a single unit. So it becomes very difficult to make predictions when we do not have all the variables with the same unit. Hence, to solve this problem, we are going to use standard scaler. What does standard scaler do? Standard scaler will ensure that everything is scaled to one particular unit. Now, let's apply the standard scaler. How do we do that? From sklearn dot preprocessing import standard scalar. Now we have to apply the standard scalar on the entire data set. So we have to use a for loop to apply the standard scalar onto all the columns. How do we do that? For call in df, we'll create an object for standard scalar. Let's call it SC standard scalar. And next step is to fit this onto the columns in our data set. So how do we do that? SC dot fit underscore transform. What do we have to transform? We have to transform all the columns. Now, remember that fit underscore transform does not have an in place equals true parameter. Hence, if we want the changes to be permanent, we'll have to reassign it onto all the columns. How do we do that? We write df call equals sc dot fit underscore transform df call. Remember that you have to put double brackets over here because you have to transform it across row and column. Now, let's look at the head. Df.head. So now everything is scaled to one unit. Now we can make predictions of our model. One last thing before ending EDA and pre-processing we have to do is plot the pair plot. sns.pairplot df. This is going to take a while. So our pair plot is ready over here. We cannot infer much from this pair plot, but it gives us the distribution of our data. Now we have completed exploratory data analysis and pre-processing. I hope everyone has understood what and why we are doing exploratory data analysis and pre-processing. Now our next step is feature selection and making the model, and then finally finding the evaluation matrix. Now let's divide our data set into X and Y. If you observe over here, our target variable is median house value and all other variables are our independent variables. So what is our x? Our x is nothing but x is equals to df dot drop. We are going to drop the median house value, median underscore house underscore value. Now, if our system doesn't know where to find this median underscore house value. So we'll have to tell our system that this median underscore house value is a column. So we will write axis is equals to 1. Now, our y variable is nothing but median underscore house value. So y is equals to df median underscore house underscore value. Now, we are going to perform principal component analysis. How do we do that? From sklearn dot decomposition import PCA. Now, we are going to create a object of PCA. Now we have seen that there are around 9 independent variables. That is we have 9 features in our data. All the 9 features are not going to be important for our model. Hence, PCA will select only those features which are very important for our model. Now, let's create an object for PCA. Let's call it small PCA is equals to PCA n underscore components equals, so n underscore components equals 4, random underscore state equals 1. So our object for PCA is ready over here. Now we have to divide our data set into training data and testing data. How do we do that? From sklearn dot model underscore selection import train underscore test underscore split x train x test y train y test is equals to train underscore test underscore split x comma y. We will give the test size. Let's give the test size to be around 20%. So test underscore size is equals to 0.2. Random underscore state is equals to, let's give it as 1. Now we have to create our x for PCA. How do we do that? We write x train PC is equals to PCA dot fit underscore transform x train y train. So all the x trains will have all our variables, independent variables. We only want a few important variables. For that, we are going to fit the PCA onto our x train, y train. Remember that if you're doing it for training data, you also have to do it for testing data. So, x test PC is equals to PCA dot fit underscore transform x test. Now we have to fit the model. If you observe, we have continuous data over here. We have numerical data over here. Our y value is median house value. So what we have to predict is the median house value. So it is numerical and it is continuous. So we will be doing a regression. Over here, I'm going to do a linear regression. So to do linear regression, we have to first import the linear regression from the sklearn library. From sklearn dot linear underscore model import linear regression. Now we will create an object for linear regression. Let's call it linreg. Linreg equals linear regression. Don't forget the brackets. Now we have successfully created the object for linear regression. Now we have to fit this model onto our X-train PC and Y-train. So linreg.fit X-train PC. Remember, we are doing it only on X-train PC, not on X-train, because we have chosen the most important features using principal component analysis. Y-train. Now we have fit our model. Now we'll have to predict. How do we do that? Ypred is equals to linreg dot predict xtest pc. Now we have to check for the accuracy of the model. We have to see how good our model is. So from sklearn, we are going to take some evaluation metrics. Those evaluation metrics are R squared, mean absolute error, and mean squared error. Now let's evaluate our model. From sklearn.metrics, import R2 underscore score, mean underscore absolute underscore error as MAE, mean underscore squared underscore error as MSE. Now let's print out our R squared, mean absolute error and mean squared error and root mean squared error. Print f string R squared so we have R2 underscore score by test by bread. So we get an R squared of 42%. What does this R squared imply? Only 42% of the change in the housing median value is determined by the four features that we have selected. Now let's look at the mean squared error. Print MSE MSE by test by bread. Our mean squared error is 0.565. So our error is not very high, it is quite low. So our model is quite good in predicting the median house values. Now let's find the root mean squared error. So we have found the root mean squared error. Our root mean squared error is 0.75 and our mean absolute error is 0.57. So our errors are pretty low. I hope everyone has understood the exploratory data analysis, pre-processing, feature selection, model creation, evaluation metrics. Thank you.